Morning, everyone. Did I study my baby talk? Well, not exactly babbling yet, but I'll do so when she starts. Hi, Ezra. Hi, Downey. Hi, Sean. Hi, Hayden. Hi, Charlie. Hi, Hike. I was killed off. Hi, Vinny. Hi, Ryan. I emailed you back, Ryan. Take a look at your email if you didn't already. So, a lot was posted. Hi, Jack. Morning, Josh. Saw your message. Obviously, up in the upper left corner, deadlines for things, and then we'll work back from that. Due Wednesday is Tour of the Solar System. So, from our research to a finished recording of your slides is what we need to do from now until the end of the day on Wednesday. And then submit that. And obviously, I'll show you each step. Today, though, we're just focusing on starting the slides, maybe getting half of your research into a slide. All right, and then Thursday is your online DNA sheet due before midnight. Obviously, turn it in whenever it's done. All right. So our agenda for today, specifically, doing DNA number 1, which is again under references or right underneath today's daily post. Review the rubric and objectives for a tour of the solar system so you know what you're working on and why. And then letting you work on your slides, answering any questions you might have about what I'm expecting or about your planet or whatever. Alright, so the first DNA of the week, kind of using last week and where we're going for this week. What is the classification of the object known as Pluto? Which criteria of being a planet does Pluto fail? So thinking back to last week, the 3 criteria for a planet, which one does it fail? 1, 2, or 3? And what is its actual designation? What is its classification? If you need a hint, and we're going to look at these shortly, I have slides, and several of you are in it, about Pluto. I used to use these slides introduced to the class Pluto as a topic for discussion in determining a new definition of a planet. We would have a debate in class, people who would want to keep the definition the same versus people who would want to change the definition, or 2 competing definitions would have a debate in class, which is like a Socratic seminar, except you want a winner. And we would redefine what a planet would be based on this idea of what happened to Pluto. Alright, so I'm going to kind of use these slides to show you sort of what you should be including in your slides, or how they should maybe look a little bit. This is not an example, though. While you're working on that question, I did update the rubric. Again, you're in box 1 for our online sheet. Each question is worth 2 points. 2 points for usual, very detailed answer. 1 point for just bare minimum. So 1 out of 2 for bare minimum. and then 0 for something blank. I changed your ratings. Since, we're not really going to be in person and learner qualities are currently being thought of being removed from your report card for T3, I've changed this to being graded as whether you turn in your sheet on time or not. So that's an easy 1 point for following a deadline, following directions, and being accountable. All right, so the daily sheet is now, or the DNA sheet is now worth 9 points total. Okay, 4 questions a week, that's 8, 2 points a question, and then 1 point for turning it on time for following a deadline. Since these right here probably will not be showing up on your report card for T3. That's not a quote, just a possibility. Morning, Ava. So I'm going to go through these slides, and then we'll talk about a final answer. Oops. So a little background on Pluto. In the 1840s, you got to work a little backwards. Neptune's discovered by Urbain Le Verrier, a French astronomer. He's able to predict the existence of Neptune based on the orbit of Uranus. Okay, so there's an irregularity in Uranus's orbit, an eccentricity slightly off center of the sun, and he's assuming that there's another planet kind of pulling that planet outward. All right. In the 1900s, early 1900s, Percival Lowell in Boston starts looking for a 9th planet after analyzing disturbances in the orbit of Neptune. He calls this planet X because X, being a variable, an unknown in math, becomes part of its name. He dies before making a discovery, even though he takes a picture of Pluto without noticing it. Going back through his teacher, his boss's work, Clyde Tombaugh in 1930, confirms the existence of a 9th planet, confirms the existence of this object that we end up calling Pluto, which was suggested by 11-year-old Venetia Burney in Oxford, England. Pluto's Roman god of the underworld. It's the most distant object that we were able to discover. Name is voted on because Percival Lowell's initials are in the name. Ooh, what's up with the formatting here? Yeah, let's try that. There. Sorry about blocking some of that. So if we go through distance learning all year, will there be something that will change our grades in a big way, like testing? I'm not sure what you mean by that, Rainey. You're going to have assignments, you'll be getting grades. Establishing the Kuiper belt. So there's an area of objects past Neptune that we ended up discovering in the 1990s with better technology using Hubble and other systems. We find out that there's other objects that we name Eris, Makemake, Kamehameha, Quar, Orcus, Sedna. Some of them are very weird looking in that they're kind of like little footballs. Others are what they would appear as like a planet. Because of this, appearing similar to Pluto, in the same region as Pluto, the discoverers of Eris want to make it a 10th planet in 2006. However, the IAU wants to meet because if they start allowing Eris in, then they're going to start allowing maybe hundreds of objects similar to Pluto and Eris into this family of being a solar system. So they meet to discuss what a planet would be, and they come up with these 3 criteria. Object must orbit the sun, object must have enough mass to be spherical, and object must have cleared the neighborhood around its orbit. Pluto and the other Kuiper Belt objects are classified as dwarf planets because they fail criteria 3. So if you are looking for an answer for DNA number 1, these are the 3 criteria. These are what the KBOs, or TNOs, Kuiper Belt objects, trans-Neptunian objects, you become classified as. Okay? So Pluto fails criteria 3 because there's other dwarf objects in, or other small planetoids in its area. Gets kicked out. Because only real planets are allowed in the club. You take a look at some of these videos. They're pretty interesting. One's about the New Horizons mission and NASA being able to describe it, show what it would be like, and then NASA or another website putting out information about what happened when New Horizons went by in 2015. And people still like to have fun with Pluto having feelings. New Horizons did not stay in an orbit around Pluto. It just flew by and took thousands of pictures while it was flying by. So Pluto is normally drawn as a cartoon with that heart because there is a ice plane on the side that New Horizons saw on its approach that kind of looked like a heart. The rest are, again, like other geological features, a lot of craters. The red is something called a tholin, which are organic molecules made from cosmic radiation. The white is obviously ice, this ice being mostly nitrogen, water as hard as rock. Okay, the layering of Pluto, there's a crust of frozen nitrogen, water ice underneath it, and then a rock interior. Don't know how far, what material it extends in, because we don't have anything on the surface of Pluto to really measure any kind of activity. However, there's a recent article saying that there was rippling on the surface, and that suggests that this water ice might actually be an ocean. How? Because of Pluto's very large, in comparison, moon, Charon, possibly these two pulling on each other so much, the tidal forces involved, the friction involved, might melt the ice underneath Pluto's nitrogen crust. Wouldn't the frozen water break the rock? The water has already expanded and is frozen solid, Eric. So you're thinking of water as it's freezing, expanding. This is water that's been frozen and is as hard as rock because it's so distant from the sun. Water expands when it freezes, not when it's frozen. It's not going to keep expanding. But you're not entirely wrong, because those ripples that they said they found could be from maybe a subsurface ocean, the very furthest part of the ocean freezing and then causing cracks. So why are we calling it frozen water and not ice? Because I really want you to understand that this is frozen and as hard as rock. I don't want you to think of ice as ice that we normally think of as ice. I'm being real particular, real weird. Because when I think of ice, I'm thinking of ice that goes in a glass to drink with, right? This is ice that is, like I'm saying, as hard as a rock. Ice cubes aren't hard like a rock. They can break apart relatively easy. When New Horizons reaches Pluto, we get more information on its other moons, smaller objects, probably other captured KBOs, Kuiper Belt objects. Pluto is smaller than the Earth's moon. So there is an actual size comparison there. This was a video from after the IAU demoted Pluto to a dwarf planet. This lady interviewed Bill Nye. Bill Nye is, not actually a scientist, but he did do, Bill Nye the Science Guy, so people ask him questions about science. And in this video, you don't have to watch it, but that was just there to show how a middle school debate should operate, because at this point in time, we would be focusing on trying to prep for a debate on whether we should change the definition of a planet and what should the definition change to. So just some basic background knowledge on Pluto. What you're really focusing on is slide number 4. And that this is not technically a perfect definition, because it must have cleared the neighborhood around its orbit. Well then, how do rings factor into that? How do moons factor into that? And that was one of the questions from the quiz last week. I asked, just because something has a moon, does it mean it's not a planet? And I said no, because the moon orbits the planet directly. Well then, what about something like Jupiter, which has groups of asteroids getting pushed by it or pulled by it around the solar system? Those aren't orbiting Jupiter exactly, and they're in Jupiter's orbit. So should Jupiter even be considered a planet according to criteria 3? That's a question astronomers and planetary scientists can go back and forth on. Alright? So this is not a perfect definition by all means, but it is the definition that we use currently, and that's the one I'm having you learn. In previous debates, in previous years, we've had that definition where an object must have an atmosphere instead of clear the neighborhood. And so because Jupiter's moons, Ganymede, Io, Callista, Europa, and Saturn's moon, Titan, and some other moons across the solar system have atmospheres, according to that definition, they end up getting called a planet. So, sorry, Eric. So, changing the definition has unintended consequences. But this is what you're focusing on. If your brain's hurting, this is what you're focusing on. What is the classification of Pluto? Which criteria of being a planet does Pluto fail? Pluto is a I don't know why it's doing that. There. Pluto is a dwarf planet because it fails criteria. Number 3 of Pluto is a dwarf planet because it fails criteria number 3 of the definition of a planet, which means it's called a dwarf planet because it can't clear its own neighborhood orbit of similar objects. It's a little crowded. Even though there's a lot of space out there, they're still in a similar orbital area. When I say they, I'm talking the other dwarf planets in addition to Pluto. Eris, Sedna, Makemake, Himeamea. And so what we're left with are 4 inner planets, 4 terrestrial planets, rocky planets, and then we're left with then 4 outer planets, 4 gas giants. Mercury, Venus, Earth, and Mars are closest to the Sun. They're inside the radius of the asteroid belt. And then Jupiter, Saturn, Uranus, Neptune are outside the radius of the asteroid belt, and then outside Neptune's the Kuiper belt, where Pluto is. What's past the Kuiper belt is called the Oort cloud, which is where all the comets are. If you want a visual, we'll be using this at some point. If I zoom out, this is the supposed view of the Milky Way galaxy. If I zoom in, going into our little neighborhood, these are some nearby stars. Sirius gets pointed to by constellation Orion. Pollux is one of the stars in the Gemini constellation. Vega will be our future North Star. Remember, there's no up, down, left, or right, so it's all relative position. The Sun's right there in the center. We zoom in a little more. Proxima Centauri, Alpha Centauri. Here's the beginning of our solar system. This hazy area around our Sun is called the Oort cloud. Trillions of little icy objects left over from the solar system's formation. They become comets. Gravitationally, they get pulled into the center in very weird elliptical orbits by different means, and they end up going into the inner solar system. So it extends more than 1 light year out, our solar system. Keep zooming in. See how far away that Oort cloud is? Now we're starting to see orbits. But keep in mind, these orbits, Neptune, Uranus, Saturn, Jupiter. The outer solar system doubles in distance as you're moving out. Neptune is incredibly, incredibly far away. The inner solar system is right here. These 4 little dots are the inner planets. So remember, from the center dot, our star, to the third dot, the Earth, is 8 light minutes away. This is incredibly, incredibly distant space. So the orbits start coming into view. And then you have the inner solar system. Asteroid belt exists here in between Mars and Jupiter. Kuiper belt exists here outside Neptune. And we've seen that before on NASA's own little visualizer. Trying to have that 3D model again. There it is. You can see the dwarf planets on weird tilts in their orbits in the Kuiper belt out here, and then inside Jupiter we have the asteroid belt with larger asteroids marked, Ceres being a dwarf planet itself. So we've done our DNA, kind of briefly led into tour of the solar system, the 8 planets. Review the rubric one more time, the objectives for tour of the solar system, and then you're going to start making your slides if you haven't already done so. So under classwork, tour of the solar system, rubric, 6 criteria, 24 points. The first criteria, the first strand, is based on geology and meteorology. Did you include research information in your slides on surface conditions, landmarks, the interior layers, interior conditions, and then any weather? So what would the surface be like, or what does it look like from space? Any landmarks, any things with names on them? What's the interior like? And the weather. You can make that 1 slide, you can make that 4 slides, you can make that 2 slides, however you want to see fit. So like surface conditions and landmarks, those probably actually go together. Interior would probably be its own, and weather could be its own, so there could be 3 slides. It doesn't have to be 1 slide for each, but if you want to make it simple on your organization, you can do that. Simple being, it's a little extra in terms of all the slides that you can kind of condense a couple of these. Astronomical phenomenon. Distance from the sun, rotation period, revolution period, mass and surface gravity. These two could probably be put together. Rotation period and revolution period. So if you're making slides, you can talk about distance from the sun, you can compare it to the earth, you can talk about light minutes, how many light minutes is it away. And then on the next slide you can talk about how fast it spins on its axis, how long a year is together, and then mass and surface gravity. How much mass does it have? How much surface gravity does it have? How fast does something fall if you drop it? Miscellaneous research. The other things, maybe you find something else that's really cool, or maybe you find information about moons, rings, and other missions to the planet. Include that as well. That would kind of be their own slides, though. Is there such a thing where all the planets align? Yeah, it's just incredibly, incredibly rare. Last full planetary alignment. Well, the next one's going to be on May 6, 2492. The last time they appeared 1,000 years ago, 949. So 949 to 2492. We're looking at a difference of about 1,500 years to get from one to the next. Incredibly, incredibly rare because you need 8 objects to synchronize in their orbit. And we found out that our planets do not have resonance anymore, so it's even harder to do so. What's resonance? Go watch my video, what would happen if the gas giants collided. How many slides are required? Back on topic. Eric, I say no more than 13. So there's no specific number required, but don't go beyond 13. I'll get to that in a second. Why 13? These are all your content. All the slides for your content. The slides themselves have to have high-level organization. They have to have cohesive fonts. You're not playing with fonts all over the place. Colors aren't a mess. Images that are included are applicable. There's no memes in there. I don't know if Jonathan Leach is watching. I didn't see him in chat. No memes. Incorporation of sources per slide or at the end. So then also, to get 4 out of 4 points, make sure your sources are linked on each slide that you use them for, or make a final slide at the end with all your links on them. A works cited. Communication. Make sure you're being clear, but then you're also engaging. You're being informative. Gets a 4 out of 4 there. That's when you're narrating your slides, or maybe writing a little paragraph explaining your slides, whichever way you want to do it. No winking, Rainey. Vocab. Using the vocab that you find in your research and that we've talked about. Orbits, asteroid belt, Kuiper belt. Moon is okay, but you can also say natural satellite. That's also a good vocab term. But just using scientific terminology. Alright? So these 3 right here are about the slides or your narration. You can either record your narration or you can write it out and submit it. I'll go to that in a second. Alright? And then the first 3 on the rubric are about your content, the categories of research. Alright? So if I close out of the rubric and actually open up the assignment, why did I say no more than 13? Because there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 research boxes that you should have done, right? So 11 research boxes. Maybe 1 title slide is a good idea, right? And then 1 slide at the end for your sources. So 11 plus 2 is 13. 1 title slide, 11 research slides, and then your last end slide with all your sources. Probably the easiest way to do it is 13 slides. However, that's probably not the best way to do it. Like I said, you can chunk some of this information together. Like surface conditions and landmarks, they could probably go on the same slide, right? Rotation period, revolution period, they could probably go on the same slide. Does that help explain? Chill. When we are done, I'll write it out again, Rainey. When we are done with our slides, we're going to use Screencastify, record them. And I have a video you can watch tomorrow and Wednesday to help you use Screencastify to be able to record your narration of your slides. You'll probably have to do it in part 1 and part 2. So you could do and then I'll show you in the video how to link each one. They can be in whatever order makes sense to you, Ryan. If you think my order made the most sense, use my order. You want to use your own order? Use your own order. I'm not going to take points off if they're out of order, but they got to make sense. If you just start putting random things, like randomly, then that's just going to be bad in terms of your cohesion, your theme. Alright? Like, for example, if you start talking about surface conditions, then jump to rotational period, then jump to the interior of the planet, and then jump back to like mass and surface gravity, then that's no order, that's just you jumping around. Okay? You can have your own order, but it's just gotta make sense. Mr. G, for the last piece of research, it's called ring system. What should I put because Mars doesn't have one? Well, You say it has no ring system, then that's all you can do. But I would do a little more research, Eric. You can say there are no rings, like other planets, and just move on. Some planets will not get penalized for not having moons or rings, but you have a lot of missions to your planet, Eric. So if you're not going to have something about the ring system, I would go in depth on the missions to your planet. Okay. So, in all, again to answer your question, Rainey, one title slide, 9 to 11 research slides, and then one source. So 11 slides, 11 to 13 total. Your research slides come from your table. You can make your own order. You can follow my order. You can chunk a couple slides together, or you can do a separate slide per topic. So looking at 9 slides, that's chunking together surface conditions, landmarks, that's chunking together rotation and revolution. You're eliminating 2 slides by putting things that are very similar in information together. I went fast through my Pluto presentation when I recorded a video on how to use Screencastify, and like some of this isn't even very text heavy, and I skipped the videos, and it took me about 3-4 minutes just to do that video. So you will probably be going more than 5 minutes, and if you're doing that, you're going to need a part 1 and a part 2. So I would maybe stop recording. We'll talk more about this later. We're going to stop recording probably halfway through your research, halfway through the number of slides, and then just hit record again and record a second part. Every time you use Screencastify, the video is uploaded into Drive, so that all you got to do is just copy a link, and then you can just highlight over part 1 and then just paste it in, and you can highlight over part 2 and paste it in. So Screencastify is pretty easy if you follow directions and you just pay attention to your screen. But again, you don't have to narrate yourself. I put that as an alternative so you didn't have to write a CER after doing all your research. But if you want to just write out an explanation, write out how you'd explain your planet and the slides, you can do that. I would include it in this box. You could link your slides in, but I'd also want to see the CER in that box too. Can we put together more stuff in one slide, or are we allowed to do the ones you said? No, go beyond what I said, Hike. If you have more information, you can make an extra slide. That's fine. Maybe, though, I would just kind of save time and make sure we're being concise. Maybe chunk together surface conditions and landmarks, and chunk together rotation revolution, so that you have 2 extra slides that you can put whatever you want on that's applicable, using your own research, your own topic. Then you'd still fall into that 13 slide limit. Hopefully that makes sense. Like, I don't want you going way, way beyond 13, because then you're going to take a long time. You're already cutting into 2 parts. So I would chunk together things to make up room for other research that you want to include. For distance from the sun, does it matter if we use kilometers or miles? Always give the kilometers. If you want to give me miles too, then you can do that. Give me kilometers because it is the standard unit of measure in science. All the other countries use kilometers. But all the scientists, even in the United States, use kilometers. So, in part of thinking like a scientist involves using units like a scientist. So you can give me both, but don't leave out kilometers. Answer a quick email question. How many slides do you need? Any other questions? The goal for this week, or how this week should progress, and you can always check the distance learning plan if you want to see what the plans are moving forward. You know, where you click attendance, there should be a link further down below for Mr. Gervasini or Science Distant Learning Plan, DLP. You can click that and see what's coming up next, but that's what I'm getting to, Logan. Today, I would do half of your slides. Think of it as doing part 1. If I'm going to have 13 slides, I'll do 6 because your last slide doesn't really count. It's just your links to your sources. So today I would do 6 slides. Tomorrow I'll do 6 and finish up my source slide. So today I'll do 6, tomorrow I'll do 7. I'd break up my slides in half. Alright? It's a lot of pasting in, formatting, and thinking about what you would say and how you would explain your slides. Alright? So today you're doing the first half, tomorrow you're doing the second half. Wednesday you kind of finish up your slides if you need more time, and then you just record. So if you're ahead of the game, you don't need to finish anything up. You just record your slides, you link them in to your tour document, and then you just turn it in. And that's Wednesday. I'll also have a form for those of you that want to share out your planet and your presentation. I would hopefully try and get one of each planet, and we'll listen to on stream and watch the ones that volunteer. And so we'll actually have a tour, according to you, of the solar system. That would be my best case, ultimate goal. Wednesday, you record, you finish up. Thursday, we kind of watch together some of the presentations you guys made. And then Friday is nothing new. Friday, we review for the DNA quiz. And then you just take the quiz, and that's it. If you need more time for something, to finish your presentation, to do revisions, use the rest of Friday to do that. Okay, so that's the week at a glance. That is in the weekly update that was emailed out to your parents last night. That's in the DLP. It's always there. Can rings around the planet be considered landmarks? I'm going to say, Jack, no, because there's a whole research box for rings. If you're thinking of a gas giant, what kind of landmarks could be on a gas giant? Most of the gas giants have features on their atmospheres or in their atmospheres. I would use those named features. Like, just be real obvious, Jupiter has the Great Red Spot. That would be a landmark. Even though it's not really land, it's still a specific feature that has a name. Saturn has one. You got to look in the North Pole of Saturn. There's something very weird at the North Pole of Saturn. Uranus, you could talk about the tilt of the planet. And then, yeah, Neptune has really just one, and it comes and goes. So some planets can talk about other things more than others. For Neptune, you'd be talking about the rings more, you'd be talking about the moons more, you'd be talking about the interior, because the gas planets have very weird interiors. So those are the things. So some planets have more things to research in other categories than others. If you're an interior terrestrial planet, you probably have more information on surface conditions, specific features, interior, and atmosphere and weather. Well, you have more information on conditions on the surface and specific landmarks and features. If you're a gas giant, you probably have more to include for interior and atmosphere and weather. Okay? If you're an outer solar system planet, you probably have something to talk about in terms of rings. If you're an inner solar system planet, you probably don't have a lot to talk about with rings. But then you have a lot to talk about with other categories, like missions. So it depends on your planet. Each planet is a little different in how it presents information. So Ryan has a very common question I've been getting. And it's, should I name all of my planet's moons? If you're in the inner solar system, there's only 3 moons total out of 4 planets. You can name them all. Jupiter, Saturn, they have a lot of they have a lot of moons. So what should you do? You should tell me the total number of the moons, but then describe to me the 4 largest. So you don't need to name them all. Just tell me Jupiter has 60 some moons. And then you go in depth on Ganymede, Io, Callista, Europa. For Saturn, you go in depth on 79. Ooh, I was off. For Saturn, you go in depth on a couple of the moons that probably are in the rings. And similar for Neptune and Uranus, the 4 largest. Or the more famous or the most prominent ones. But no more than 4. So we'll bring it back here. A title slide, source slide, those are easy. If you got about 10 research slides, you're doing about 5 today, plus your title, and then 5 tomorrow, plus your sources. So, kind of break that in half. Do the 4 largest, Ryan. That should answer your question. The 4 largest should have the best pictures. Like I've been saying, Rainey, do about half. If you think you're going to have 12 or 13 slides, do 6 or 7 today. Good. Hopefully that's a little more official for you. And just so you know, when you're making slides, I think I've turned the view off. But there is a little area where you can click and drag up, and you can click to add speaker notes. So I can plan out what I would want to say for this slide. Like there is water ice on the surface of Pluto, where most of the ice, or frozen water if I'm Azra, where most of the ice is nitrogen. So you can actually plan out what you want to say. Now when you present, you can't see that, but I mean, I could open up my slides on another device and be able to take a look at it. Or I could write on a piece of paper. That's even better. Could write out what you would want to say. But that's another class. That would be Wednesday. How can I record myself better? A little more information about resonance and other objects. Maybe we'll take a look at this later, but Hayden asked a question a little while, like a couple classes ago. Under Ask Mr. G playlist, there's what if the moon blew up? Does the sun have a shadow? We're going to come to this after Tour of the Solar System. And then what would colliding the gas giants do? Take a look at that at some point, because we'll be using each in one way or another. This one we'll be using towards the end of the solar system when we talk about stars in general. And then this one, again, talking about exoplanets. So that's coming up after Tour of the Solar System. But again, I'm getting ahead of myself. Today, 6 to 7 slides. Tomorrow, 6 to 7 slides. If you guys have any other questions, email them, send them through Reminds, and I'll help you. Alright? But we're near the end of our time. Math's up soon. Any final questions? No? Sounds good. I'll see you guys tomorrow. Bye, Ezra. Bye, Johnny. Bye, Ryan. Bye, Rainy. Bye, Hike.